this lecture I am going to revise the previous lectures what we have discussed up to now, and we will discuss again some more theories of Laplace transform. So first I will revise. Okay, so to revise I wrote some formulae that we have already discussed in the previous lectures. So first is Laplace of t to the power a when a is positive numbers. Then what is this? Gamma of a plus 1 divided by s to the power n plus 1. In the second formula, when this a is a positive integer or 0, 0, 1, 2, 3 like this, then in that case Laplace of t to the power n, suppose n is 0, 1, 2, 3 like this, then the value will be n factorial divided by s to the power n plus 1. Already we have derived this in the previous lecture. Third formula is what? Laplace of e to the power at is equal to 1 by s minus a. Next is Laplace of sin at is equal to a divided by a square plus a square. Then Laplace of cos at is equal to s divided by a square plus a square. Difference is in sin at numerator is a, in case of cos at in the numerator it is only s. Then go to the next formula, Laplace of sin hyperbolic at it is a by a square minus a square, and in case of cos hyperbolic at it is s by a square minus a square. Already we have derived, and in the previous lecture already we have proved that what is a fast shifting theorem in Laplace transform. So what is the theorem? What is the statement? If Laplace of f of t is written as f of s, then Laplace of e to the power at into f of t, if we multiply some exponential function e to the power at with f of t, then its Laplace will be what? F of s minus a. If it is Laplace of f of t is f of s, then Laplace of e to the power at into f of t will be f of s minus a. Okay, so I will do 2 more examples to revise all these things. So now suppose Laplace, we have to find Laplace inverse of 3 divided by a square plus 6s plus 18. 3 divided by a square plus 6s plus 18. Now to find the inverse of this function, Laplace inverse of this function, what do we have to do? 3, then since here it is a square plus 6s, so we make it or we can write this term as a square, like a square plus 2 bracket 6s means 2 into 3 into s, right? Then plus for 18 we can write 3 square plus 3 square. 9 plus 9 is equal to 18. Now Laplace inverse of what? 3 divided by, and this part will be written or can be written as what? S plus 3 whole square and plus 3 square. Now since in bracket, this bracketed term is s plus 3, not only s, it is s plus 3. So since it is s plus 3, what I have said, if it is s plus 3, surely we have to apply fast shifting theorem. Is not it? Surely you must have to use fast shifting theorem, and since it is s plus 3, so how to apply the fast shifting theorem? Whose Laplace transform is this function? So suppose this is not s plus 3, it is only s. Consider this is only s. So now you can check 3 divided by a square plus 3 square. 3 divided by a square plus 3 square. So if it is 3 divided by a square plus 3 square, so whose Laplace transform is this? It will be sin 3t, we know that according to this formula. According to this formula, it is sin 3t. And since it is not only s, it is s plus 3. Okay, so according to fast shifting theorem, s will be shifted. S will be shifted. So what we can write, that if it is s minus a, we have to multiply e to the power 80. If it is s minus a, we have to multiply e to the power 80. So here it is s plus 3, so we have to multiply e to the power minus 3t. What is a here? It is minus 3. So it is e to the power minus 3t. Right? So the final answer is what? E to the power minus 3t into sin 3t. So this is the answer. We have to use fast shifting theorem, we have to use the formula of sin 80 simultaneously in this problem. Similarly, go to the next example, that Laplace inverse of 12 divided by s minus 3 whole to the power 4. Okay, so since you can check here, s is shifted by 3 here. It is not only s, it is s minus 3. So since it is s minus 3, again we have to use fast shifting theorem. Right? So since we have to use s minus 3, so what is a here? A is 3. So what we have to multiply? We have to multiply e to the power 3t. It is okay. E to the power 3t will be there. Is not it? E to the power 3t will be there. So, and the rest part is what? So consider this is not only s minus 3. So consider, suppose there is no 3, only s is here. Only s is here. So it is 12 by s to the power 4. S to the power 4 means just come to the formula number 2. Formula 2 n factorial s to the power n plus 1. Okay. So s to the power n plus 1 means if it is 4, we can write it as 3 plus 1. We can write it as 3 plus 1. And similarly in the numerator, it is 12. What we have to write? If it is n, it must be n factorial. So since it is 3 plus 1, so in numerator it should be 3 factorial. So for 12 we can write 2 into 3 factorial. For 12 we can write 2 into 3 factorial. So now we can apply the formula 3 factorial divided by s to the power 3 plus 1. 3 factorial divided by s to the power 3 plus 1. Okay, already we have tried s minus 3. We have to 3t. We already multiplied e to the power 3t because it is s minus 3. So for only 3 factorial by s to the power 3 plus 1. So what is this formula? Laplace of t to the power n. So the inverse of a 3 factorial by s to the power 3 plus 1, it will be tq because of this formula. So it is tq, and since it is s minus 3, we have to multiply it to the power 3t, and 2 is again is multiplied, so take it out. So 2 into tq to the power 3t. 2 into tq into e to the power 3t. Clear? Okay. Now I will discuss a new theory, that is Laplace transform of derivatives. So what is Laplace transform of derivatives? Already we have discussed Laplace transform of a function f of t, that is integration from 0 to infinity and e to the power minus st f of t dt. Now if f of t, suppose f of t has a derivative of dash t, that means f of t is differentiable and its first derivative exists, and both f of t and f dash t satisfy the existence conditions. So what are the existence condition? They must be piecewise continuous, and they must satisfy the growth restriction, that is it must not increase exponentially. So these are the existence conditions. So suppose they satisfy existence conditions f and f dash t, so that means what? Its Laplace transform exists. Their Laplace transform f of t and f dash t both exist. So if Laplace transform of f of t and f dash t exists, then what will be the Laplace transform of f dash t? The derivative of f of t will be what? Laplace of f dash t equal to s into Laplace of f of t minus f of 0. How to show this? So from the definition we can write like this: Laplace of f dash t. Laplace of f of t is what? 0 to infinity integration e to the power minus st f of t dt. This is for f of t. So since we want to find Laplace of f dash t, so in place of f of t it is f dash. It is f dash. So in place of f of t we have to write f dash t. In place of f dash t, in place of f of t we have to write f dash t. So we wrote here f dash t. Right? Now to integrate this, suppose consider this as second function, this as first function. Consider this as first function and f dash t as second function. So if you consider like this, then if you integrate using by parts, first into integration of second minus derivative of first into integration of second whole integration, is not it? So using that formula by parts, so first into integration of second, integration of f dash t. So what is integration of f dash t? Derivative and antiderivative. Integration is antiderivative, so that's why e to the power minus st into integration of f dash t means it is only f of t. So e to the power minus st into f of t. Then minus derivative of first. So that is e to the power minus st into minus s. E to the power minus st into minus s. And integration of second, again it is f of t only. Then whole integration of this. So it is whole integration 0 to infinity minus s e to the power minus st f of t dt. And this is the limit from the first part, means to the first part 0 to infinity. So if we put the upper limit, it will be e to the power minus infinity. So for this it will be 0. E to the power minus infinity, it will be 0. Now for the second, for the lower limit, it will be e to the power 0 minus 1, then f of 0, right? So 0 minus f of 0 from the first part. Then from the second part, from the second portion, so this minus and minus, it will be plus, then takes s because we have to integrate with respect to t, so consider s as constant, so take it out. So s into integration from 0 to infinity, is not it? Then e to the power minus st f of t dt. Now if we compare with the definition, this is nothing but your definition of Laplace of f of t. From the definition you can check here, integration from 0 to infinity e to the power minus st f of t dt. So for this term we can write Laplace of f of t. This is Laplace of f of t. Now what we got? S into Laplace of f of t. Here s into Laplace of f of t, and from the first bracketed term it is only minus f of 0. So our result is what? S into Laplace of f of t minus f of 0. So this is the proof. So Laplace of the derivative of f of t, when Laplace of f dash t is s into Laplace of f of t minus f of 0. You should remember this. We have to apply this formula in our solution of differential equation in the next. So we should make a note here that if Laplace of f dash t is s into Laplace of f of t minus f of 0, can we find Laplace of f double dash t if it exists? If Laplace of means if the double derivative of f of t exists and it satisfy existence condition and its Laplace transform exists, then what we can find? Laplace of f double dash t. So Laplace of f double dash t will be what? Laplace of, we can write f double dash t as f dash t whole dash, as f dash t whole dash. Now consider f dash t as f of t. Now consider f dash t as f of t. Then we can use this formula. You can use this formula. How to use? Here it is f dash and here it is in the note, it is f double dash. So we have to write in place of f, we have to write f dash. So it will be what? S into Laplace of f dash t, then minus, in place of f we have to write f dash, so it is f dash 0. S into Laplace of f dash t minus f dash 0 according to this formula. Now again you have to use this formula. S into Laplace of f dash t again. F dash t means S into Laplace of f of t minus f of 0. S into Laplace of f of t minus f of 0. Then minus f dash 0. And if you multiply s with this bracketed term, so it will be s square Laplace of f of t minus s into f of 0 minus f dash 0. Minus f dash 0. So what you got? The power of s is decreasing gradually, is not it? S square into Laplace of f of t minus s into f of 0 minus f dash 0. So if you check here, the power of s is decreasing. So similarly, you can find Laplace of f triple dash, Laplace of f fourth derivative of f, is not it? So if I want to write the Laplace derivative, means Laplace transform of nth derivative of f, what will be this? Okay, so you can write